Next, we have the cross product. This is something new. The cross product of two vectors in space gives the vector that is perpendicular to the plane that contains the two vectors. So if I had vectors A and B, okay, there would be a plane that would contain them. When I find their cross product, which is written with an X, it looks like multiplication, but it's called the cross product. This would literally be, say, A cross B. It gives the vector that is perpendicular to the plane that those two vectors are contained in, okay? So now, how do you find the cross product? This actually kind of goes back a little bit to matrices. And so if you remember how to find the determinant of a matrix, that's one thing. And that's kind of what this is doing. Now, if you don't remember how to find the determinant, I'm going to show you everything right now that you need to know. This is the formula, okay? Nobody's going to memorize that formula. Here's how you can figure it out, okay? So instead of writing it in component form, we're going to write it as a linear combination with ij and k. So this is always your ij and k. You take your first vector and you write it here. You take your second vector and you write it here. Okay. Now, to get these, okay, because this is the same as this times I and this times j and this times k. I wrote this down 3 times so that I can circle stuff here. So the first thing I do for my I coefficient for this very first one is I find the determinant of this 2 by 2 matrix, okay? So if you remember how to find the determinant of a 2 by 2 matrix, I take this product minus this product. So if you go back up here and you look, a sub 2, b sub 3 minus a sub 3, b sub 2, okay? So that's where that one comes from. So this determinant times I, that's my first number in my vector, okay? Then we have the second one. Again, I'm going to take the determinant of this 2 by 2, so I'm going to take a sub 1, b sub 3 minus b sub 1, a sub 3, or a sub 3, b sub 1, okay? Now notice this one, my j coefficient, my middle term in my vector, is going to have a negative coefficient in the front, okay? So that's one quirky thing that you have to remember. Then for your k, for my last one, I cross these out, and I find the determinant of this 2 by 2. So I take a sub 1, b sub 2 minus a sub 2, b sub 1. So you don't have to memorize this, okay? You can take ijk, write it out on top, and then put, and the order that these go in doesn't matter. You're going to end up with the same answer. However they give it to you, if they ask you to find this one, cross this one, you're going to put this one here and this one here. Later on when we're doing some problems, I'll show you that it's not going to matter. For this one though, you do want to put this one second and put this one third in the second row and then the third row. And then you're finding that its determinant is what you're doing. Quirky thing again is that this, your j coefficient, your middle term in your vector, is going to have a negative, it's going to be the opposite, okay? So let's go through and try one. Oh, come on. All right, so they are asking us for these to find the cross product, and then they're asking us to also show that u cross v is orthogonal to both u and v, okay? So they're asking you to find that perpendicular vector, they're asking you to find the cross product, then they're asking you to show that they're orthogonal, which if they're orthogonal, it means that the dot product is 0. So we're going to do a cross product, and then we're going to do 2 dot products is what we're going to do, okay? So the cross product of u and v, I'm going to take I, j, and k, and then I'm going to take 4, 2, negative 1, and then I'm going to do 5, 1, and 4. So for my first one, I'm doing this right here. I'm going to have 8 minus a negative 1. That's going to be my I coefficient, okay? Then it's going to be a minus. This one is opposite. Then for my j, I'm going to have 16 minus a negative 5. And then for my k, I'm going to have 4 minus 10. So this is going to be 9i minus, I can change in those, so that's where the 9 comes from, and then 16 plus 5 is 21, so this would be minus 21j, and then 4 minus 10 is a negative 6. Okay, and whether you write your answer like this, or whether you write your answer like this, it does not matter. You can do it either way, okay? Now, it says, find the cross product. There's your cross product. This vector should be orthogonal to both of those vectors. That's what they then want you to show, okay? So I'm going to do the dot product of my cross product in u, and I should get 0. So I would have 4 times 9 plus 2 times negative 21 plus negative 6 times negative 1. So 36 minus 42 plus 6 equals 0. There's my first one. And then they want us to do the cross product with v and show again that my dot product is 0. So this one is going to be 9 times 5 plus 1 times negative 21 plus 4 times negative 6. So I have 45 minus 21 minus 24, which again is 0. And so I found the cross product, and then I showed that the dot product with u and the dot product with v is 0, which means that I am showing or proving that this is orthogonal to my 2 original vectors, which that's what it's supposed to do. Okay? So let's do one more. Here are my 2 vectors, u and v. I'm going to find their cross product, and then I'm going to show that they're orthogonal, show that my cross product is orthogonal to my 2 original vectors. So cross product I, j, k. I'm going to put this one next, and then this one last. So for I, I'm going to have negative 4 minus a negative 3 times I, so that's going to give me a negative 1i. For j, I've got a minus, okay, and I'm going to have negative 8 minus, try that again, oh jeepers, minus a negative 15 in front of j, and then plus my last one for k, it's going to be -2 minus a -5 times k. So this one would be 7, so -7j, and then this one would be 3k. All right, so -1, -7, 3. Again, whether written this way or this way, it does not matter unless they specify in the directions that it's supposed to be written in one form or the other. If they just say to write a vector, either one is acceptable, okay? But then they want you to show that your cross product and the dot product with u is equal to 0. So it's not enough to just say it equals 0. You have to show that you're going to have -2 times -1 plus -1 times -7 plus -3 times 3. So I'd have 2 plus 7 minus 9. There's my 0. And then, again, you cross with v and the dot product with v. So again, I'm going to show the same thing. I'm going to have 5 times -1 plus 1 times -7 plus 4 times 3. So I've got -5 minus 7 plus 12, and that equals 0. And so that's showing that the dot product of the cross product and each vector is 0, which proves or shows that they are indeed orthogonal.